the kids, I think, not in here, I don't think, but in some of the other hours, and they were saying that they felt like they needed a little bit more time on this, and that's not anything new, because it's been in years past that I've had to go back over this chapter once more for it to really flush in and get a better understanding. It depends, because this I knew coming ahead of time, so I've been thinking about it last night tonight before the test. When it really gets to me is if everybody is giving me the thumbs up, kind of, okay, we understand this, we got this, and then we get to a test and the average is in the 60s or below, then it's a little bit frustrating. Yes. So there will be different assignments to this. It won't be the exact same assignment, so there's not going to be 7. There's going to be 4.
So do you want to turn the ones in from last week and then the ones that are coming?
Yes. So the assignments from chapter that we covered already are still due at the end of the day of the test. So you've got an extra time for those to get those done and turned in. It was supposed to be tomorrow. So since the test is not tomorrow, it'll be when we have it again, when we actually take it. So there is extra days there. Because I was looking back last semester, I didn't recover it. I made a video of me going through the video, or me going through the test and kind of doing the corrections, and y'all watched it and made them up. But I don't want to have to do that to where it's less of y'all actually doing well in the test and more coming back and then making corrections. I want y'all to actually do well on the test. So we're going to go through and do it again. Now, for the most part, getting these ready, it didn't take too long for me to actually get the note sheets ready for y'all, because they've been ready to go already, because I've had to go back and do it again. Now, hopefully this will help clear in some of the gaps. If you already understood a lot of this and you were good to go, you're going to be fine. You're going to blow through these and the homework should be easy. If you did have some misunderstandings or didn't understand certain parts of it, we'll cover them here. All right? And again, if anything doesn't make sense, asking questions is helpful, because I think earlier today they did ask a few questions and I rephrased it and it made more sense. Because with any of the stuff we cover in here, I'm going to cover it the way I understand it best and it came to me best. And I think it's the easiest way to do it. But if it doesn't make sense, ask. And I'll try to rephrase it or try to reword it so that it hopefully does make sense. So with this here, so there will be 4 worksheets that are attached to this that go along with it. And today, what we're mainly covering is, if I can get to the right slide, direct and inverse variation and least common multiple. Direct and inverse and least common multiple. Now this is the first part of the chapter, inverse, that we cover at 7.1. I was talking about direct and inverse variation. And least common multiple we covered later on. Now our direct variation, if I get a pen, came in a few forms. And the main version of the equation was y equals a times x. This is the main version of the equation that we kind of work with, and that's just by definition what it is. And really, it's just relating 2 variables, x and y. And when they're in a direct variation, they're both either increasing or both decreasing. They're both going in the same direction. So really, if I wanted to, I could think of the equation as x is equal to a times y. And a is just a constant number. It could be a fraction, it could be a whole number, it could be decimal, it could be positive, it could be negative, it could be any number. We just treat it as a. It is a constant term. Now we also showed that if we got a by itself, so here we divided both sides by x, we do get the direct inverse or direct variation equation, a is equal to y over x, where a is just the constant term. So if any x and y in this here, we divide them, we'll get that constant term. We can do the same with this one here is really just telling us a is equal to x over y. And it's the exact same thing. And it is one of the nice things with the variable a, thank you, the constant term a, is that it actually works out in that kind of interesting way. We'll pass the stapler around here in a second. You're welcome. You're welcome. So far all we've gone over is just the equation. And these are just the different versions that we can have for direct variation. Just manipulating the equation. Now, for inverse, the main equation that we have is y is equal to a divided by x. Well, if we wanted to, we could really also say that x is equal to a divided by y. Because we do have a tendency of wanting these to be y by itself, but really, x and y are just two variables. One has been denoted as an input, one is denoted as an output. And we've come to the conclusion, or kind of gotten used to, x being the numbers we plug in, y is the numbers that we come out of the function. But it could be either one. We just have x and y. And again, with this equation, we can get the constant term a by itself by multiplying both sides by y or both sides by x, telling us that a, the constant term, is equal to x times y. That if it is an inverse variation and we multiply the values of x and y together, we should get a constant term. It should be the same amount for any of the x and y in the inverse variation. An inverse, as one increases, the other is going to be decreasing. And as one decreases, the other is going to increase. And when we talk about decrease and increase, we're really talking about one is either going to 0 or one is going to infinity. So if it's increasing, it's getting closer to infinity. It's getting to be a bigger number. That could also be negative infinity. It's going away from 0. And if it's getting smaller, it's getting closer to 0. And I think that'll help, especially when looking at negative numbers, because we do have, it is true that -2 is bigger than -4, but as we look at the numbers, which one's getting closer to 0? Well, it is going to be decreasing if we're going from -4 to -2, because we're getting closer to 0. Now, what we're going to do is we're going to look at these here, and probably these are going to look familiar because we've covered these once before, is defining each one of these equations as direct or inverse variation, or neither. And the first one we're going to look at is x times y is equal to 5. Would this be direct, inverse, or neither? What do we think? It would be inverse. Because this does match up to our x times y is equal to a, because that is one of the forms of inverse, is our x times y is equal to a. Now, we could solve this and get y by itself by dividing both sides by x, telling us y is equal to 5 divided by x, which would be an inverse variation. And with any of these here, we could actually get them in the form of y equals and actually graph it. So if we said y equals, I don't need either one of these here, because we said 5 alpha y equals x. And if we graph these here, an inverse is going to be these two separate ones. And as we go away from 0 on either one of these here, x is increasing how to do this. Okay. X is increasing, but Y is decreasing. It's getting closer to the x-axis. And going the other direction here we're getting farther away from 0 on the x, but the values of y are getting closer. They're going in opposite directions. It's an inverse. And all the inverse variations will actually have this shape of two kind of curves. Okay. Now, what about B? What do y'all think? Neither. And the big giveaway is what? Yes. Neither. The minus. Because with our x and y, if they're on opposite sides, they're not connected to each other, and we have any addition and subtraction, most likely it's going to be neither. If we do have the variables multiplied together, we have x and y multiplied together, and there's plus a number, then it's a good chance it could be one of the others. But if those variables are separated and we have addition or subtraction anywhere in it, it's going to be neither. It's not going to work. And the last one would be direct. I mean, one way we can tell is because, well, we've already had inverse and neither, so most likely it's going to be direct. But the other is we can consider doing the placement of x and y. X and y are both in the numerators. They're both in the top of a fraction, yes? And in both of our equations, y equals a times x, and y is equal to a divided by x. And we're mainly looking at the ones because x and y are on opposite sides of the equal sign. We're looking at these here. Well, the only one where both x and y are in the numerator is when it is a direct variation. The 2 is just our constant term. It's our value of a. So one way we could have looked at this is saying 1/2 times y is equal to x. That 1/2 is still our value of a. Because a is just a constant term. It's any number. It could be a whole number, or it could be a fraction, it could be a decimal, it could be positive, it could be negative. So 1/2 in this case is a. Well, we could multiply both sides by 2, and these would cancel, telling me y is equal to 2x. So it's still in that direct variation. In this form, a is 2. Questions on this here? You ready for the next one? Our next set of 3, really. So we can go top to bottom. We can go with the first one, 6x is equal to y. It would be direct. Because this is more forming with the y is equal to a times x. We can also kind of see it that both variables are in the numerator. We don't have one in the bottom of a fraction. So it'd be direct. How about number 2? It would be inverse, yes. Now it might be tempting to say that it is direct because, like we were saying with the last one, both of the variables are in the numerator, yes? But different from the one before, where is x and y? They're not on either side. They're on the same side of the equal sign, yes? And they're being multiplied together. It's coming in the form of x times y is equal to, hey, it's our inverse. Because if we got them onto opposite sides, we would have had the equation y is equal to negative 0.25 divided by x. It is now in the denominator. Does this make a little more sense? Yes? And the last one, y plus x equals 10. Is neither. Because we cannot have the x and y being added or subtracted. It doesn't work. Because whenever we're relating x and y, especially on the same side, they're either multiplying are being divided. It's either multiplication or division. And that's it with these three here. Questions on these? We'll do three more, and then we'll move on to the next type. And we look at the first two, yes, it would be inverse. Because we have x times y is equal to 17. Well, that's our x times y is equal to a. It's just telling us the constant term is a. How about the next one? It would be, exactly. Neither, and kind of the big giveaway is x and y are on opposite sides, and we have a plus. And lastly, y over 10 divided by, or y divided by 10 is equal to x, would be. It would be direct, because again, x and y are still in the numerator. So really our value of a is 1/10, 1 over 10. Any questions on these here? I think for the most part, y'all found inverse and direct variation pretty good. We were good with those there. So it's not a bad place to start. Now, direct variation and inverse variation with these numbers, I think looking at these now and thinking about the numbers as either they are approaching zero or going away from zero as increasing and decreasing will help us to be able to see which one is more likely going to be. If we look at a, the not the numerator, but the x values are 2, 4, 6, and 8. So these are going away from zero. They'd be increasing. Or the denominator, negative 12, negative 6, negative 4, negative 3 are going closer to zero. So we can say that this is increasing and this one here is decreasing. So most likely this is going to be what? Direct, inverse, or neither? Inverse, because if it's going to be one of the two, most likely it's going to be inverse because they're going in opposite directions. And the way that we can determine that is from our y times x is equal to a, because that is one of the general equations of inverse if we get the variable by itself. So what we can do is with each one of these here, multiply the x and y values. So we can say 2 times negative 12 is negative 24. We can do 4 times negative 6, which is negative 24. Well, that's kind of promising, but we do need to go all the way through because I think for some of you who did finish out the notes or the review sheet, there was one at least on that worked well all the way up to the last one and then it went way off. So we do need to make sure going all the way through. And 6 times negative 4 is negative 24, and last but not least, 8 times negative 3 is, well, negative 24. Since we got the same value for all these here, a is the same, it means it's an inverse. This is an inverse variation. And that's all we need to do for this here. And as long as one of the two works, since we saw that y times x equals a gave us the same value all the way across it. Kayla, let's turn around. Thank you. We don't have to test for direct variation, because if it's one, it can't be the other. It's either going to be direct or inverse. It can't be both. Any questions on this here? So if we look at the next one, 1, 2, 3, 4, well, these are going away from 0, so they are increasing. 2, 4, 8, 16. Again, they're going away from 0, so they're increasing. And really, we could have thought about it going the other direction also. 4, 3, 2, 1, well, they're going closer to 0, so they are decreasing. And if we look at the y value, 16, 8, 4, 2, going the other direction, well, they are also decreasing. They're going either way we go. They're either both increasing or they're both decreasing. So since they're going in the same direction, most likely this is going to be a direct variation. And our direct variation would be y divided by x is equal to our constant term, a. So we can start off with 2 divided by 1, which is 2. That's kind of nice. Our next one would be 4 divided by 2, which is 2. So that looks like it's going to be direct variation, yes? Looks like it. What's the next one? 8 divided by 3, which we know is not 2. Because we need it to be 2 for this to be considered direct variation. Because 8 divided by 3 is 2 1/3 or 2.3 repeated. That's not what we want, so it's not going to be direct variation. And if we wanted to check inverse, we could say 2 times 1 is 2. 2 times 4 is 8. Okay, well those aren't all the same, so it's not direct or inverse, so it has to be, yeah, neither. This is neither. Interestingly enough, the equation for this is y is equal to x squared. It's a quadratic equation. But it's not a direct or inverse variation. Questions on this here? Okay. We'll do 2 more of these and then we'll move on to least common multiple. It's the last thing we're going to look at today. Now we look at number 4. What do we think it's most likely going to be? Direct, inverse, or neither? Because if we look at the numerators, -4, -3, -2, and -1, going this direction is getting closer to what? 0. 20, 15, 10, 5. These are all getting closer to what? 0. They're all going towards 0. If we went the other direction, they would both be going away. So if they're going in the same direction, would it be direct or inverse? Not direct, because they're direct. If it's direct variation, they're going in the same direction. Either they're both increasing or both decreasing. Inverse, we're going in opposite directions. One's increasing, one's decreasing, or one's decreasing and one's increasing. So most likely, if this is going to work out, if we divide y by x or x by y, either one, we should get the same number. So we can take 20 and divide it by -4, which would give us -5. We can do the same thing with the next one, 15 divided by -3, which would be -5. 10 divided by -2 is -5, and last but not least, 5 divided by -1, well, is -5. So we do get the same term by dividing y by x. Now, it is possible to do x divided by y for this here, and it would give us the same number, but it wouldn't give us -5. It would actually give us -1/5. It's just flipping it. And it would give us the same number, telling us that this is a direct variation. Any questions on any of this here? So what do we think the next one's going to be? Inverse. Because if we look at the x's, they're getting bigger, kind of approaching infinity. And the denominator, or the y values, not denominator, are approaching 0. So what we should expect to see is that we have a constant term when we multiply x and y. And our first one would be 1 times 60, which would be 60. The next one would be 2 times 30, which is 60. We can do 3 times 20, which is 60, and last but not least, 4 times 15 is also 60. So it does work that we do get this constant term, and it's telling us that this here is in inverse. Questions on this here? Least common multiple. Least common multiple. What we're trying to do here is to find the smallest number that we can increase all of the terms to be, which I've always found interesting because we're talking about the least, but we're actually making them all bigger, putting more to it. And this here is really helpful when we start talking about our complex rational expressions. So when we have our fractions inside of fractions, it's helpful, and especially once we start solving. Especially once we start solving. Because if we can find the least common multiple, the smallest thing we can actually turn all the denominators into, and actually when we talk about denominators, they call it the least common denominator, because it's talking about the bottoms of the fractions, which really are the same thing. It's just what we're looking at. It's going to help us solve these a lot easier. Because anything we go above this least common multiple is going to add factors in the top and bottom. It's going to increase it by whatever that is. And it works out, especially when solving, the additional answers we add are actually just restrictions, which don't work anyways. So we want to find the smallest thing we can turn these into. So when we look at the first one here, 16m, negative 12m squared n, and 8n squared, we want to see what we can turn all three of these into and be the smallest that it is. I bet that's really interesting, Trey. So, the first thing we want to look at, yes. So, yeah.
Oh, sorry, that is so rude. But,
I keep the door locked just in case it does shut and I'm not in here. I don't want to lock the keys to this room in here. So always hang on to them just in case. Well, none of those actually have my car keys on them, so it doesn't help. Does that kind of answer? So, looking at this here, the first thing, because we want to look at, since they're just individual terms, is we want to get 16, negative 12, and 8 to be the same. And we're looking for the smallest number to make all those three to be the same. Now, one way we can do this is actually looking at the multiples of 8, 12, and 16, and see which number is the first one that we can turn all three into. Well, 8, 16, 24, 32, 40, 48, and then we would have 56, and it would continue on. Well, 12 is 24, 36, 48, 60, and we continue on. And 16, we have 16, 32, 48, well, okay. Well, 48 is the first number where you can turn all three of them into being the same thing. And I have a feeling that problems like this here, where it asks, say, the least common multiple of these three numbers that showed up on an ACT that y'all taken, or at least for the ACT prep class, we've talked about least common multiple of three numbers. The graphing calculator will do it. But unfortunately, it only does two numbers at a time. And I'll show you, so in math and under number, the 8th one down is least common multiple. It'll also do greatest common factor or greatest common denominator with two numbers. So if we go down and select least common multiple, well, two of the numbers that we had were 8 and 12, or 8 and 16. So we can do 8, comma, 16. Well, the least common multiple between 8 and 16 is actually 16. Now, if we grab it again, because we had another number, well, we can say that the other number was 12, comma, 16. And the least common multiple between 12 and 16 is 48. So on the ACT, when it does ask this, you can pull the calculator up. We go math, number, 8th one down. Or even if you forget that, at least remember it's in math. Scroll through the first one. If it's not there, bump over one, and we'll be able to find it. And it'll do any two sets of numbers. Do the first two, see what it is, and combine it with the next one. So that helps us out some, as it tells us for these three numbers, our least common multiple is 48. Now, since the 12 is negative, the 48 has to be negative, because we're trying to make them all be the same, all be the exact same. Now, for m, here we have m squared, and we don't have any m's. So what's the most that m appears in any of these? Twice, because it does appear once in the first, but in the second one we have it. So in the final answer, I need it twice. And lastly, we have no n, and n squared, so we'll need n squared. So we actually get this here. Any questions on any of this here? Okay. Let's look at this one here. 5xy, 15x squared y, and 10y squared. Yes. 30 is going to be the first number that we can turn all of these into. And really, we could ignore the 5 because the least common multiple between 5 and 10 and 5 and 15 would be 10 and 15. So it's really looking at the least common multiple between 10 and 15, which is 30. It's going to be the first number. Now, if we look at the variables, x squared, and well, the last one doesn't have an x, the most that it occurs in any of these is twice, so we'd have an x squared. With y, no y and y squared, so yes, we would need a y squared, because in any of them, the most it occurs is twice, so we need it twice. And lastly, we would have a z. And we only need it once, because in any of them, it only occurs once in any of the individual expressions. And that's it. All right. Let's look at this one here, x times x minus 2. So we need, this one here is kind of interesting, because how many times does x occur? Once, because the x minus 2 is one whole term. And we'd also need n x minus 2. So it actually worked out to be just x times x minus 2. It's kind of interesting when it works out that way. Any questions on this here? All right. Unfortunately,